Hi everyone. In today's lesson, we're going to look at sex chromosomes. We're going to try and figure out how it's possible for people to create biological males and biological females. But the first thing that we have to realize is your sex chromosomes is the last pair of chromosomes in the human genome. Okay, pair number 23. So the sex chromosomes both are involved in determining gender, but there's usually only two types, an X chromosome and a Y chromosome. For the most part, you guys already know that if you're a male, you should have one X chromosome and one Y chromosome, and if you're a female, you should have two X chromosomes. But in terms of how you get those chromosomes and what gender you're likely going to become, it all depends on the male. Gender is actually determined by the male. And that's because the females, since they're females and they only have two X chromosomes, okay, they can only pass on an X chromosome to the offspring. Okay? There's no choice for the female but to give an X chromosome. So by default, since males have both an X or a Y, we can pass along either an X or a Y to the next generation. Therefore, males are actually the ones that are responsible for determining gender in our species. So if a male sperm is carrying an X chromosome, okay, whenever that sperm fertilizes the female egg, okay, it will pair up with the other X chromosome, therefore making a homologous pair. Okay, so both X chromosomes are about the same size. They carry the same genes on both chromosomes. But if a male sperm carries a Y chromosome, okay, when that sperm fertilizes an egg that is carrying an X, you have a male, because now you have a non-homologous pair. You have an X chromosome, which is much larger than the Y chromosome, which is much smaller. Now, there is a problem that is basically a common problem throughout history. Okay, so this guy here, he's King Henry VIII. King Henry VIII was infamous for having 6 wives, and he basically wanted to divorce all of his wives, or in some way behead the wives, or get rid of wives in some way. And there's this kind of urban legend. Okay, the popular belief is King Henry was so obsessed about having a male heir to the throne of England that anyone who couldn't give him a male heir or a son was basically either beheaded or divorced or gotten rid of. Okay, history tells it a little bit differently. Okay, there are some things that were true. He did have 6 wives, but he also had 3 children, and of those 3 children, the first 2, yes, were girls, but he did eventually get a boy. And he was actually the first person to basically introduce the concept of divorce to the church. So he, I guess, did a lot of things, but he also got a lot of things wrong. Okay, because again, his belief was the female is the one who basically determines gender of the child, and it was the mother's fault for not being able to give him a son. And today we now know that's really not true, right? So even though he did blame his wives for not being able to provide him with a male child, it was technically his fault. Okay, and that is a common misconception that people still have today. Okay, in some cultures, okay, in some societies, whenever a family or a couple doesn't get a male, okay, or I guess even a female, they always blame the mother. Okay, but the fault is technically on the father's side, because his sperm basically decides whether the child is going to be a male or a female. Okay. So to summarize again, if the father has a sperm carrying an X chromosome, you're likely going to have a female. If the father has a sperm that's carrying the Y chromosome, if that one fertilizes the egg, then the offspring will likely be a male. Now, it sounds like it's 50-50, right? You either are going to be a male or a female. You can't be something, in between, but statistics doesn't seem to work out that way. Okay? It's close to 50-50, but not quite. Okay? We considered this to be a type of gender imbalance, okay? Like a biological imbalance, not gender inequality. That's something a little bit different. Okay, so even though you have two choices, an X or a Y, it should be a 50-50 probability, but it kind of depends on a bunch of other factors. Okay, nature does have an influence over whether there might be a situation where more males might be created or more females, okay, or even less males or less females. It also depends a little bit on culture too and the environment. So there's a video here that I'd like you to watch. I don't know how the quality will be, okay, but I'll also provide a link to this video under Google Classroom, so that if you can't really hear what's going on, okay, when you're watching this particular presentation, you can just click on the link and then watch the video on its own. But we'll give it a try here and see what happens.
Here's a bright idea. Gig speed internet.
Actually have it set up already.
Most parents-to-be assume that the sex of their child comes down to a flip of the chromosomal coin, with an equal chance of having a boy or a girl. But in reality, the odds aren't even. For every 100 girls born, the world gains about 106 baby boys. Currently, that skewed sex ratio comes out to roughly 10 million more baby boys than girls born worldwide each year. There are some countries where human meddling stacks the odds even higher in favor of boys, but that doesn't explain the fixed odds everywhere else. The intrinsic boy-girl ratio is rigged by Mother Nature. In fact, it's even more rigged than birth rates show. Human conception results in about 150 male zygotes for every 100 females. But there's a rather tragic reason for this big biological boy bias early on. Male fetuses are much more likely to be miscarried or stillborn than female fetuses. And boys that do make it out of the womb suffer more fatal diseases, take more mortal risks, and fall prey to more violence than girls. So by the time kids grow up and reach baby-making age, the ratio of males to females is just about 1-to-1. But the likelihood of a boy even making it to birth is also influenced by his mom's living conditions during pregnancy. For example, when a massive famine struck China in the 1960s, the relative likelihood of having a son suddenly dropped, until the famine ended. And male Americans born to billionaires seem to have higher than average odds of fathering sons. Somehow, female biology suppresses boy survival in the womb during tough times and boosts it when times are good. We've seen the same pattern in other mammals too. When resources are scarce, mothers give birth to fewer males than normal. When resources are plentiful, they bear more. The best explanation we have for this has to do with sex, the other kind. In biological terms, the whole goal of copulation is to reproduce, to pass down your genes to someone who will someday pass them on again. Female offspring are almost guaranteed to reproduce, famine or no famine, because male mammals are pretty much always willing to mate. Males, on the other hand, have to compete for mating privileges. A well-nurtured hunk has a good chance of mating with lots of females, while a male weakened by famine might not score at all. So male offspring are a bigger risk in general. At all stages, they're more likely to die, and even if they live, they might not reproduce. But when times are good, boys' potential to father lots and lots of babies make them a biological risk worth taking. Thanks to everyone who supports us on Subbable. Without you, we literally couldn't continue to make these videos. If you aren't yet a supporter of Minute Earth and want to become one, head over to subbable.com/MinuteEarth to make a one-time or monthly pledge of support. And thanks for watching.
Okay, so there are a lot of different cultural reasons or environmental reasons that could affect the 50-50 ratio between men and women on this planet. We won't necessarily discuss that here right now, okay? But we'll probably end up discussing a little bit more about it when we see each other in class. Now, the one last thing about your sex chromosomes. Your sex chromosomes do contain dominant and recessive genes that are only found on the sex chromosomes. And these genes can also affect other characteristics other than gender. Okay, we have talked about one of these characteristics before. They're mostly called sex-linked. So the one that we have discussed briefly before is basically color blindness. So being a male, I have a higher chance of being colorblind than females. So when you have certain genes on the sex chromosomes, your gender kind of influences whether or not you have these conditions. Sometimes they're disorders, sometimes they're just regular types of characteristics that really isn't a disorder at all. But we'll get to that when we talk about sex-linked genes in its own section, because it is a very broad topic, and there's a whole bunch of different things that we can look at in the near future about it. Okay, that's all I have for today. Thank you very much. Take care.